Bismillahirrahmanirrahim. Previously, we talked about sum of arithmetic sequences. So if you were asked to find the sum of n number of terms, we learned this formula where you take a sub 1 and a sub n, add them together, and divide by 2 times n. So that's the sum of n number of terms from an arithmetic sequence. And also, just for as a reminder, we have the recursive and the explicit rule for defining individual terms of an arithmetic sequence. Now today I'd like to derive this formula, and it's reasonably easy to do. So when we're asked to find the sum of a certain number of elements from arithmetic sequence, what do we first mean? I guess the first thing we have to say, what do we mean by finding the sum of a certain number of terms? So for example, if I'm given a sequence such as a sub 1 and then a sub 2 and then a sub 3 plus dot 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 all the way up to a sub n, right? Okay, so to find the sum of these, okay, would mean that what we really want to do is we're creating a series. So the sum of n number of terms would be a sub 1 plus a sub 2 plus a sub 3 plus, okay, all the way up to, let me move that up a little bit, all the way up to a sub n. Now just to make it a little bit more exciting, I'm going to write a couple of terms backwards over here. So what's the term that comes before a sub n? It's going to be a sub n minus 1 term. And then the term that's before this one is going to be a sub n minus 2 terms. Okay, so when we're saying we want to find the sum of n number of terms, basically if this is what we mean. We're trying to find the sum of this series, correct? Okay, now we know that in an arithmetic sequence, a sub 1, a sub 2, like this, a sub 3, like that, right? And all the way up to a sub n, that's n minus 1, and then there's a sub n minus 2 here. Okay, I hope you understand. So the way we generated terms from a sub 1 to a sub 2, just we added it to 2, right? So we added not a 2, we added a common difference. So we just added the common difference. So we added a common difference, and etc. All the way up to here, we added a common difference. We added a common difference. Astaghfirullah. I added a common difference. We added a common difference. We added a common difference. That's how we get the terms. So you can just rewrite this as saying the sum of a sub 1. Now a sub 2 is just basically a sub 1 plus 1 common difference, correct? And then a sub 3 is a sub 1 plus 2 of those differences, right? Plus all the way up to a sub n, right? Now a sub n, to get from here to here, okay, that's really interesting. To get from here to here, let's go with this. You have to subtract a d, right? So a sub n minus, so we have a sub n minus d will give you this, right? Just like if you have to add over here you have to subtract a d. Going backwards, you have to subtract a d, right? So that's what we're doing over here. I'm subtracting a d from a sub n to get to n minus 1 term. So in other words, I'm going to rewrite this term in terms of a sub n minus d. Okay, so I take a d from this. And then I can write this term, that's a sub n minus 2d, correct? Okay, so in other words, okay, to get to from here to here, I can subtract a d, and to get from here to here, I have to subtract another d. So I can rewrite this term, okay? So I can rewrite this term as this, and then I can rewrite this term as this term. Okay, so that's not so bad. Okay, so we have kind of just basically rewritten this thing. So to find the sum of this arithmetic sequence, therefore, is just adding a1 to an. So a1 is this, a2 is this, a3 is this, and all the way to the an is the term before it, and this is the term before it. Now what we do is actually quite an ingenious mathematical trick, T-R-I-C-K. What I'm going to do is I'm going to rewrite this same thing, except I'm going to write it backwards. In other words, I'm going to bring this in the front, right? And then this over here, and then I'm going to take this in the back. I'm going to kind of flip the whole thing, okay? And I'm going to like flip the whole thing. So I'm going to write over here, in other words, okay, I'm going to write a sub n, okay? And then I'm going to write this term over here. I'm going to write that over there. And I'm going to write this term over here. I'm going to write it over here. I'm going to just kind of reversing the order of the terms. Okay, so then if I do that, I have a sub n minus d plus a sub n minus 2d plus dot 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 plus, okay, now I'm going backwards. The last three terms are going to be these three terms. So that's going to be a sub 1 plus 2d plus a sub 1 plus d plus a sub 1. Okay, so that's weird, you think, right? So wait, I wrote the sum, right? And then I wrote the same sum backwards. So I just changed the order from first to last and then last to first, okay? Okay, why did I do that, you say? Well, this is why I did that. So what I'm going to do now, see, okay, I'm just going to add these two rows. Excuse me, I'm going to add these two rows. I'm going to this plus this. So on this side, you get 2 times the sum. Okay, I can't do that. This is just a number, right? It's a sum. You can just add them. They're just numbers to me. So over here, I have a sub 1 plus, it becomes a sub n. But now look what happens, though, see? See, this d cancels out this d, okay? This 2d cancels out this 2d, and all the way across, this 2d cancels out this one cancels out this one. So all I'm going to have left is, okay, all this a1s and a-n's. This a1 and this a-n. Because this cancels out, this cancels out, this cancels out, this cancels out. Okay? And then I have, okay, over here, I'm just going to write them in as a1 plus a-n in this order, plus a1 plus a-n, and then I have another finally in the last over there, a1 plus a-n. Okay, so I have a lot of bunch of a1s and a-n's, right? How many a1s and a-n's I have, you want to say? Okay, well, you see, it's like 1 pair, like 2 pairs, 3 pairs, all the way up to the end, right? How many of those terms do I have? I have n number of terms, so I have n pairs, right? So it's going to be n number of a1 plus a-n, right? So because this is a pair, this is a pair, that's 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 a pair. How many pairs do I have? I have n of those. So it's going to be n of these pairs. Got it? That's 1 pair, that's another pair, that's third pair, all the way up until the end. Okay? I'm almost there. Now look. And then I divide both sides by 2. Okay? I divide both sides by 2. Then I get the sum of what I was looking for, the arithmetic of the sequence is going to be, okay, right, n times a1 plus an, okay, and that's going to be divided by 2, which is what I have over here. Now you say, oh, the n is on the other side. That's okay. You got it. Okay. So that's how you derive. This is a pretty reasonably easy proof actually to do, and this is the sum of an arithmetic sequence. Now you know, as beautiful as this proof is, as easy as this proof is, I actually don't memorize this formula because there's some other beautiful way of remembering this, and I'd like to share that with you, which I actually have done before. Now, if you recall, there was a gentleman named Carl Friedrich Gauss. We talked about him before, I think. Carl Friedrich Gauss is known as the Prince of Mathematics. He's a great mathematical genius. And presumably, when he was 7 or so, his teacher, just to keep the kids occupied in class, told all the students to add all the numbers from 1 to 100. In other words, the teacher told them to find the sum of all the numbers 1 to 100, like 1 plus 2 plus 3 plus 4 plus ... plus all the way up to 97 plus 98 plus 99 plus 100. Okay? And Carl Friedrich Gauss's genius was within seconds. He said, "I have the answer." And he wrote in his little slate, and he gave it to the teacher, and he said, "The answer is 55,050." And he got that within seconds. Now, how did he do it? I don't know how he did it, but his is a mathematical trick, okay? So what he did might have been like this. He added the first and the last term, okay? And that gives a sum of 101. And then he took the second term and the second to the last term, okay? And that gives you 2 plus 9, which is 101. And then if you take the third term and then you add it to the third term from the other end, okay, that gives you 101. And then if you take the fourth term and add it to the fourth term from that, you get 101. So you get 101. And then how many 101s are there? Okay? And all you have to do, how many 101s are there? Well, he's dividing right in the smack in the middle, right? You're taking one from here, one from here. There are 100 numbers, so they're going to be half as many, which is 100 over 2. Okay, and this is 50/50. Okay, now this formula, okay, this method is very similar to the formula that we derived, okay? Because this is basically a sum of an arithmetic sequence. This is an arithmetic series, okay? So if you see carefully over here, what's going on here is basically you take the first term, and then you add it to the last term, okay? And then how many of those sums are there? They're going to be half as many as terms. It would be n over 2. And that is the formula for arithmetic sequence sum. So if you remember Carl Friedrich Gauss, when he was 7 years old and his teacher told him to find the sum of 1 to 100, and how he took the first number and the last number, second to the last, and added them together, and they're going to be half as many over there. So take the first term, add it to the last term, multiplied by the number of terms divided by 2, you get the sum of the arithmetic sequence, and that is the formula for the arithmetic sequence. The story for me is so beautiful, and so this problem is so elegant, and the pattern here is so beautiful that I don't really memorize the formula, because it's just so easy to remember if you remember the story of Carl Friedrich Gauss, of the Prince of Mathematics. Until next time, as-salatu was-salamu ala rasulillah wa ala alihi wa sahbihi. Assalamu alaikum.